Okay, let's start. Today we learn the ellipse. Ellipse belongs to the conic sections. So before we show you the ellipse, I would like you guys to see how the ellipse is formed. You will punch two nails at this two dots location, F1, F2. That's called the two foci. And then you will hold a string and fix the length. And then you will use a pen and draw it to the maximum length. In that way, you can draw a beautiful ellipse. Okay. Now, we will talk about the special properties of the ellipse. As we see the movie just now, you have two nails here. This is called foci. The difference between circles and the ellipse is, for a circle, it only has one center. For ellipse, it has two centers. This is the two center of the ellipse. One of them is called focus. You have two of them, it's called foci. And next, when you hold this guy plus this guy is going to be a fixed length. These two summation together is a constant value. It equals to how much? It equals to 2a. So if you hold your pen to this position, this as a to the right, this is negative a, which is to the left. When you hold your pencil here, this distance plus this distance, this is going to be equals to 2a. The center here, this center between these two foci is called the center of the ellipse. This distance is called c. To the right is positive c, to the left is negative c. To the right here is positive a, to the left here is negative a. And then you will go up, go down. When your pen is over here, this distance, this total is a. This part is c. So this piece is a minus c. And then this guy to here, this distance is c. This distance a. So this is a plus c. So you notice that a plus c plus a minus c equals to 2a. You're holding the same string. So that means from here to here, this two guy distance also equals to 2a. If your pen go to here, this two distance also 2a. So it's a fixed length. As long as you hold this two position and you hold your pen, you will draw a beautiful ellipse. Now, we know this called the foci. This is the nail's position. And this center is between the midpoint of these two foci. That's called the center. And then we will call this direction. This is called transverse axis. This direction, you can also call it major direction. The direction where the foci pass through, that's called the major direction, or you can say transverse. In this class, you will notice that you have a lot of new vocabulary coming in. So you notice that this direction is called either major axis or transverse axis. Next class, we will learn about hyperbola. Okay, these two are all belongs to the conic sections. This direction is called a major direction or transverse directions. This direction is perpendicular to the major direction. This is called minor axis. This is called minor axis. And then the vertices. This is called vertices. This is also called vertices. This is the vertices in the major direction. This is vertex in a minor direction. Now, I'm going to show you guys with the radical equation, how do we derive the standard equation for the ellipse? We learned this thing before. I'm going to guide you guys through this. This is the time to check if your foundation for radical equation is really good or not. Okay, so let's start. Okay. This is the ellipse, and I have this first, this focus is on the right, c comma 0. To the left is negative c comma 0. And any point on this ellipse, this line segment plus this line segment is going to be a fixed value, because when this point move to here, you know this distance here, this part is c, this part is a, so the length is a plus c. From here to here, this total is a, this piece is c, so this small piece is a minus c. A minus c plus a plus c equals to 2a. So the definition of the ellipse is any point on this ellipse, the distance to here plus the distance to here is equals to this constant 2a. So I will ask student this question. I will ask several students to walk through this with me. By the end of this class, I need everybody being able to derive this formula. Let me call student. Cindy, if my point is x comma y, how do I get this distance? Distance formula. Square root x1 minus x2 squared plus y1 minus y2 squared. Okay?
So x plus c.
X plus x minus negative c is x plus c, right?
Yeah.
And then plus y squared. This is that distance, yes?
Yeah.
How much is this?
X minus c parentheses squared plus y squared.
Good. This is equals to 2a, correct?
Yeah.
Yeah. If you still feel curious, after the class, go ahead, punch 2 nails and hold a string and use your pen to draw this, and you will say, oh, that makes sense now. Now we are going to manipulate with this formula. This is a typical radical equation, right? So we learned radical equation previously in Algebra 2. I told everyone we will solve this thing in Conic sessions. Now, from here, we want to solve it. You won't be able to solve this by square this side, because if you do this, you will have that guy square. Well, you get rid of the square root. Plus that guy square, you get rid of that, but you will introduce a new one, 2ab. That means you will have this one times this one, which makes very complicated. So what we need to do, we need to move this to the right. Make sense? That makes sense, Cindy?
Yeah.
Okay, so what I'm going to do, I'm going to copy. I'm going to paste. I will move this guy here to the right by a minus. So 2a minus this. So far, so good?
Yeah.
And next, after I move this to the right, I'm going to square both sides. Okay, let's go ahead. This guy square become?
X plus C parentheses squared plus Y squared.
So I'm going to get rid of this. I will expand the guy inside. Who is this?
X squared plus 2xc plus C squared.
And then plus Y squared. So far, so good?
Yeah.
Good. Now, I need you to square the right side. Go ahead, please.
4a squared minus 4a
yes.
times square root of x minus c parentheses squared plus y squared. Plus
let's expand this guy. Square this guy and expand the inside.
X squared minus 2cx plus c squared plus y squared.
Very good. Excellent. Every student, when you watch this, you also please quickly write down by your own understanding. Next, Annie, let's go ahead. Cancel the things on both sides, which can be canceled. Who can be gone? Which term can be gone?
X squared.
Who else?
C squared. And Y squared.
Okay, very good. Now, this is a new radical equation. To solve it, we want to move the guy there. Look, this is negative, so I'm going to move this negative to the other side to be positive. I will move this guy to the right, okay? I will make this to the left, so it's going to be positive, right?
Yeah.
So 4a times square root x minus c squared plus y squared equals how much?
4a squared.
Minus
2cx.
This is negative 2cx minus another will be
4cx.
Yes. We take care of everything already, right? This guy is here. This guy is here. This guy move to the left. Everything else get canceled. Everybody. Can every students get this step now? This is the same method as we solving the radical equation before. But previously, all those C value, A value are all numbers. So students feel better. Now everything becomes numbers. Students don't feel comfortable. This is the thing you need to drill. This is the foundation for calculus and also pre-calc. And this is 4, this is 4, this is 4. Let's divide it everything by 4. Is that okay?
Yeah.
I'm going to divide it everybody by 4. Okay, so far so good. Next, I'm going to square. Look at here. I'm going to square everybody. Okay? Now I ask you, this term square becomes to who?
A squared.
Yes.
And then parentheses.
We will have that guy. Okay, let's go.
X minus C.
We will expand this thing also. Okay.
X squared minus 2c
Good.
plus c squared. And then plus y squared.
Good.
Equals a to the power 4 minus 2a squared cx, and then plus c squared x squared.
Very good. And next, we are going to do the distribution. Let me call another student, Catherine. Let's go ahead, do the distribution, please.
A squared times x squared minus 2a squared cx plus a squared c squared plus a squared y squared.
The right part just copy down, okay? Does everybody already have this same step? Is there any question so far? Next, let's see the guy which can be canceled. Catherine, tell me which term can be canceled.
Negative 2a squared cx.
Okay, that guy can be gone. Now we are going to move. We will move the c squared x squared to the left, okay? And we will move this guy to the right. So we will have a squared minus c squared parentheses times x squared. So far, so good?
Yes.
And then we will plus a squared y squared equals to a to the power 4 minus a squared c squared. Make sense?
Yes.
In the ellipse, there is an important property. That's called a major axis. This is the major direction. This is the minor direction. This is your vertices, major direction. This is vertices, minor direction. This is A, this is B. For ellipse, there is a property. That property is saying A squared minus B squared equals C squared. A squared minus B squared is going to equals to C squared. That means this is B squared. This guy is B. This guy squared plus this guy squared is Pythagorean theorem is this. This guy exactly equals this. Okay, you can draw your own ellipse and you can measure. Hey, this thing always equal. That's for ellipse. This is a property for ellipse. So you have this formula. You have this one available already. Now, Catherine, a squared minus b squared equals c squared. So that means a squared minus c squared become a squared minus c squared will becomes what? Catherine? A squared minus c squared, you move the b squared to the other side, yes?
Yes.
So you have this guy as b squared. Now, this term can be replaced by b squared. So this is b squared times x squared plus a squared times y squared equals a to the power 4 minus a squared c squared. You will take out a squared. You have a squared minus c squared. A squared minus c squared is b squared. So this is a squared b squared. The last step, you have this guy equals this guy. What you do? You divided everybody by a squared b squared. Okay? Now, Daniel, this term divided by a squared b squared become how much? Daniel?
X squared over A.
Yes,
X squared over B squared.
x squared over a squared. You divide by a squared, b squared, right?
Yes.
So b squared canceled, you have a squared left, yes?
Yes.
And then this term divided by a squared, b squared become?
Y squared over B squared.
A squared b squared over this guy is how much?
1.
1. Makes sense now?
Yes.
Now, this is an ellipse. And now I'm going to show you guys. You know, some students during the pandemic, the school teacher just skip all the Conic sessions part so that they didn't teach kids in Algebra 2 the Conic sessions about the ellipse and hyperbola. And all those kids, when they come to pre-calculus, everyone has big trouble because pre-cal teacher assume you already mastered this part. So pre-cal teacher will just jump and make to different high level. But all the students just feel so confused because nobody teaches them in Algebra 2. So here, you can do this. You can do this calculator in the decimal. I suggest you do this. Play with this, and you will feel way more better about what I'm doing right now. So you do a x squared over a squared plus y squared over b squared. You say this equals to 1. And you say, I don't know a, I don't know b. There's no x, there's no y. What does this mean? You can add a slider. So if you feel not comfortable with this, you can say, okay, I'm going to make this as a 4. I'm going to make the b as 3. Okay? That's going to give you a ellipse. This ellipse, the a is 4. Look, this is a is 4. B is 3. So a squared plus b squared is c squared. The c, look at here. This guy here. This is a squared. This is b squared. So you have this ellipse. The a is greater than b. When the guy here, this number, under the x squared is greater than the guy under the y squared. This ellipse major direction is the horizontal direction. But you can change. You can switch. You can change this 4 to be 3. You can change this 3 to be 4. You will see this suddenly change to a vertical direction. This time, the two focus is on the y-axis. It's not on the x direction. It just depends on who is greater. The guy who is greater, that is the major direction for the ellipse. This is true for ellipse, but not true for hyperbola. So if you do a slider, if you change this to be a, and you change this to be so first I just one slider. So look, a is always positive. So I can change, I can make my a between 1 and 10. If I play this, you see the shape of this ellipse is changing just by the a value, because when a is smaller, look, now a is 1.19, so which is less than 4. That means the major direction is in the y direction. That's why this is a vertical ellipse. When you make the a increasing, you see the ellipse is closer and closer, like a circle. When a is exactly equals to 4, this is a perfect circle. The way I this graph doesn't show well because the XY ratio, and then when I adjust it, now this is a perfect circle. When my A is greater than 4, this make your guy under the X square greater than the guy under the Y square. That make your ellipse major direction come back to the X direction. So that's what's going on. Okay. Now we come back to the equation. So this is a standard equation for ellipse. What will happen if the ellipse center is not at 0, 0? You will do a shift. You call your ellipse center at x0. So you do x minus x0 square over a square plus y minus y0 square over b square equals to 1. If your center is not at 0, 0, but at x0, y0. This is the horizontal ellipse. If you want to do a vertical ellipse, you are going to put this direction. So in that way, you have to make your y square in front, and you want to put a square under, plus x squared over b squared equals to 1. This is a scenario for the vertical direction ellipse. If you don't want the center to be at 0, 0, then you do y minus y0 square over a square plus x minus x0 square over b square equals to 1. Okay? So you may say, oh, I don't like this formula. Well, your school won't test you this kind of thing. But for me, I need you being able to derive this because this is the important foundation. Your school will give you a question like this. So let's take a look. At the beginning, it is not hard. And then we will move the question harder and harder. First, let's do this. Haley, that's the ellipse standard equation. By this, we want to first divide by this for each term to change this to that standard equation. Go ahead. If everybody divide by 36, this becomes to what?
X squared over 12. Y squared plus y squared over 9 equals to 1.
Equals to 1. Now they ask you these two questions. And points of major axis. So they're asking, what's these 2 points? Okay. How much is A?
12.
A squared. This is A squared. So A is square root of 12. Square root 12 is who? 12 is 4 by 3. So you will take the 2 out, right?
Yes.
2 times square root 3. Make sense?
Yes.
So that point is who and who?
2 square root 3.
Yes.
0.
And?
Negative 2 square root 3, 0.
Good. This is called endpoints of a minor axis. So who is these 2 points? This is who?
3.
B squared. So B is 3. So this point is who?
0, 3.
Good. Another one?
and 0, -3.
Yes. So far, so good.
Yes.
Next. A squared. Do you remember the relationship between a squared, b squared, and c squared? A squared equals?
C
A is
squared.
the longest one, okay? This is B, this is C. That is A, okay? So
Okay.
A squared equals?
B squared minus C squared.
Plus C squared. So you have A squared as 12, B squared as 9. So your C squared equals how much? 3. Make sense?
Yes.
So your foci is square root 3, comma 0. Negative square root 3, comma 0. Make sense?
Yes.
This last term, you may say, hey, why you give me so many different terms here? Feel so confused. Well, that's a pace of high school. They teach you a new thing and then immediately they give you very difficult applications. Eccentricity. Eccentricity is the definition of these conic shapes, how close it is to a circle. E is C over A. Eccentricity is defined by C over A. So for circle, your C is 0. For a circle, you only have 1 point. So the C is 0. So for the circle, E is 0. If eccentricity is 0, that's a circle. For the ellipse, your C is less than A, but C is not 0. So this eccentricity for an ellipse is always between 0 and 1. Who is C? C is square root 3. A is 2 times square root 3, right?
Yes.
So this eccentricity is 1 over 2. Okay?
Okay.
A new term. Vanessa. This is called lattice rectangle. Lattice rectangle is defined by this. You have the ellipse. You have the 2 foci. If you draw the line through the foci, but perpendicular to the direction of the major direction, you don't draw this through this. You draw this guy perpendicular to the major direction. When you draw this perpendicular lines, it's going to meet with the ellipse by 4 points. This is a 4 points. This guy is called the lattice rectangle. Previously, when we draw the parabola, from this focus, parabola only have one focus. From this one, you draw perpendicular to the line of symmetry. This is called a lattice rectangle. For ellipse, you draw from these 2 foci, perpendicular to the major direction. This is called a lattice rectangle. Lattice rectangle. This is called lattice rectangle length. This is called endpoint of the lattice rectangle. Now I'm going to let you go through with me to calculate how much is this. This equation, what's this guy equation, Vanessa? That guy. Go ahead, read it.
X squared over b squared plus y squared over b squared equals 1.
So we have x squared over a squared plus y squared over b squared equals to 1. And then we can plug in. Now your x is c, so you put c here, okay? Usually when students learn pre-calculus, if you don't get a good grade, like at least 90 above, teacher will not allow you to take calculus BC. But still, some students want to take. But after you take the calculus BC, you will feel so hard. So you plug in C here, and you will move this guy to this side. So y squared over b squared equals to 1 minus c squared over a squared, correct? This lattice rectangle, the x value is c, that's why I put c here. I want to get the y value. Does this make sense to you?
Yeah.
And then we can do this one more step. This becomes a squared, and then a squared minus c squared. So far, so good?
Yes.
Okay. Student, please also write down. Don't just look or listen. Treat my class as a movie. No, that's not going to work. A squared minus b squared become? B squared, right?
Oh.
Yes. Right. So y squared equals to b squared times c squared is b to the power of 4 over a squared. So y will be plus minus. Do this guy square root. Vanessa, how much is this? Over a. Yes, good job. Now, that is saying this part is positive b squared over a, the y value. This is negative b squared over a. Same thing for here. Positive y squared over a, negative b squared over a. This length is going to be 2b squared over a, right? Lattice rectangle length is going to be 2 times b squared over a. Correct? Right. Yep. Now, when we come back to this worksheet, it's asking you endpoint of lattice rectangle. So let's see here. To answer this question correct, you want to start from the focus. Your lattice rectangle is based on this focus, going up by b squared over a, going down by b squared over a. Okay? So we will start from this. Let's calculate the b squared over a is how much? B squared over a will be? B squared is 9, right?
Oh, yeah.
A is who?
0.
What? This is a squared. A is 2 times square root 3, right?
Okay.
Does this make sense now?
Yeah.
9 divided by square root 3 will be? Nine divided by square root 3 will be? 3 times 3. 3 over square root 3 is square root 3, right?
Okay.
So from this foci, you will go up by this amount and you will go down by this amount. To save our space and time, we will have square root 3 plus minus 3 times square root 3 over 2. This is corresponding to the point here and the point here. The positive is this guy. The y negative is for this point. And then, can you use this as your apple? Tell me this guy's corresponding lattice rectangle position. Go ahead, please.
Root 3.
Negative square root 3, right?
So
Yeah, so what do you do? It's going to be just copy this guy exactly. And then you will just put a negative square root 3. That's it. Everything else is the same. Does this make sense now?
yeah.
So this question belongs to the easiest question in the Conic sessions. Now we are going to do the second one. Kathleen.
So first we're gonna divide by 196.
Okay. Go ahead, please. Everybody
And-
divided by 196. So this becomes 2x squared over who?
4.
Because this guy times 4 is 196, right?
Yeah.
Plus,
49.
good job. Equals
1.
1. Who is greater? This guy is greater, right?
Yeah.
I want to put this in front, okay? Because this time your major direction is in the y-axis, yes?
Yeah.
Now, think carefully, answer this question.
So you just wanna add the a value, right?
Yes. You want to get that guy and that guy.
Oh, the b value?
No, this is A. X is not corresponding to A. The Y, this is greater, remember?
Oh, okay.
So you want to treat this B. This is B. This is A. Make sense now?
Yeah.
Okay, so how do we do this?
Is 7. And then it's
How much?
because b squared is 49, right? So b has to be 7.
Yeah, so what's this point?
7,
0, 7, not
Okay.
7, 0. Make sense now?
yes.
Now, go get this one.
It's 2, 0 and negative 2,
We can hold this later on. Let's take care of the foci. Let's figure out how much is the C.
Wait, how do you get the c again?
The C is always using this formula, A squared as B squared plus C squared. Okay,
Okay.
let's go ahead.
So c squared is a squared minus b squared.
Yes,
And then a squared plus b squared is 49 plus 4.
49 minus 4.
Oh, which is 45 is equal to c squared,
Yes,
which is 3 root 5.
yes. So the foci is who?
0, 3 root 5 and 0, negative 3 root 5.
Good. Very good. I want you to think carefully. How do we do the lattice rectangle?
B squared minus A.
B squared over A. Look here. The lattice rectangle is B squared over A, okay? B squared over A. So we need to plug in into this vertical direction. Right now, it's going to be the vertical direction, so y squared over a squared plus this equals to 1, right?
Yeah.
Now, the foci is in the y-axis. This is 0, c. This is 0, negative c. Your y this time is c. So you plug in y equals c. So c squared over a squared plus this equals to 1, right?
Yes.
You want to this time, the lattice rectangle is not going up, going down because it's not horizontal. This is going left, going right because it's vertical. So you find out your x. Your x squared equals to b squared times 1 minus this. Yes?
Yeah.
Right. And this is a squared minus c squared over a squared, right?
Yes.
This is b squared. B squared is b to the power of 4. And you might notice that x squared equals this. So x is plus minus b squared over a. Make sense?
Yeah.
Hey, so you see, even though this is a vertical direction, but the result is the same formula. Okay?
Okay.
So, but you have to pay attention. This time is from this two foci location, move to the left, move to the right. So this guy doesn't change, but you will add or minus from here, correct?
So it's like the plus or minus and then comma 3 5.
Yes. Let's get the b squared over a first.
So b squared is 4 and a is 7.
Yes. So you will do plus minus 4 over 7, right?
Yeah.
And then copy down this. And then same thing for the other one. But you have a negative. Does this make sense?
Yeah.
Eccentricity. Go ahead, please.
It's c over a, and your c is 3 root 5 over 7.
C over a. C is 3 times square root 5 over a. A is 7. That's it. Okay?
Okay.
And you can see this is less than 1. You say, well, how do you know this? Well, square root 5 is about this, okay? And this guy times 3. This is going to be less than 7. So this is a ellipse, but it's going to be vertical direction. So far, any question? Well, you also need to draw it. How to draw it? If you have these 4 points, you can draw this so easily, okay? You know, I told you guys before, I draw so badly, but how come this gave me a beautiful ellipse? Because this software detect the points that my Apple Pencil touched and use the closest conic equations to do this curve for me. That's why if you want to go to work for those software company, you have to be good on math. Computer science major has the same math requirement as math major.
I have a question.
Yes.
How do we know if the is on the major axis or minor axis?
So the difference between these two guys is this guy here, the x squared is corresponding to a greater number. That's why the major direction is x. This guy, the y squared is corresponding to a greater number. That's why it's corresponding in the y direction. Did I answer your question?
Yes, thank you.
Okay. This is true for ellipse. Who is greater, who is major? But this is not true for hyperbola. So next week, I will specifically talk about this because several years ago, there's a sub teacher teach students Algebra 2. They said, who is greater, who is a major? And all students did wrong for the hyperbola. That's wrong. For hyperbola, you don't see who is major, who is greater. No, it's depending on who is positive, who is major. So we will talk about that thing next class. Next, number 3. Come to here. You may say, oh my gosh, who is this? You have to complete your square for your x part. You complete your square for the y parts. So you will have x minus x0 square times a number like 4 plus 8 times y minus y0 square equals to a certain number. And then you will divide by that number so that you make this right term becomes to 1. So you need to manipulate the completing square twice for here, x with x, y with y, to change to the standard format. Okay, this guy over something plus y minus y0 squared over something equals to 1. Give a try by yourself. I want to see who has very strong foundation for this part. If you don't remember my phone number, I will put here. Does anybody really need help? Unmute yourself. Nobody finished? Hey, Christina, let's go. Let's do this. We want to take care of x first. So we pick 4 out. So this become?
Becomes x squared plus x because there are 4x.
Because that's x, right?
Mhm.
But if we want to complete the square, we will on purpose put a 2 and then times 1/2. 2 times 1/2 is 1, so that this match, right?
Yeah.
We put 2 so that we can do this guy. We find out who is b, so that is a b, correct?
Yeah.
Yes. So that's going to be plus 1/2 square. So far, so good?
Yeah.
And then plus 8 take out. Y squared plus who?
3y.
3y. And then we will do a 2 times y times 3/2, right?
Yeah.
So that we can find the b. Yes?
Yeah.
You don't take out 2, you don't easily find the b. So this is a b. So you will plus this guy squared, right?
Yeah.
So far, so good? That makes sense?
Yeah.
Equals 13, negative 13 to this side, positive 13, plus who? This is the extra thing. You have to balance, so you will times 4 times 1/4, which is 1, so you will plus 1, right?
Yeah.
So this is 4 times 1/4 plus 8 times 9/4, yes? So far,
Yeah.
so good?
Yeah.
So I'll have to make this one squeezed over here, okay? Now tell me, who is this then? This is a plus b, right?
Yeah. It'll be x plus 1/2 squared.
Square plus, who is this?
Plus y plus 3/2 squared.
This is 1, yes?
Yeah.
How much is this?
18.
So this is 19, right?
Yeah.
19 plus 13 give you how much? 32, correct?
Yeah.
And then you divide by 32. Go. Next step, you do it.
And then it'll be x plus 1/2 squared over 8.
This guy over 8, this guy over?
Over 4.
Yes. Daniel, you didn't have that term correct. So far, I didn't receive any students' correct answer. I will call several students to ask which part you have trouble. You can still send me your work info if you are on the way. Yes, clear, that's right. Which part of student have trouble? Making this thing, make this part? Raise your hand if you have trouble for doing this by yourself. Okay, so if you haven't learned Algebra 1 with me, you have trouble. I don't blame you, okay? If you have learned Algebra 1 with me, but you still cannot do it, I will not be happy. Daniel, you can unmute yourself. Previously, in Algebra 1, we have something like this. Like that, right? You have the parabola. Yeah, I say, okay, you need to give me the vertex format. So what do? You take out 4 first. You do x squared minus 8x. Correct, Daniel?
Yes.
And then what you do? You always need to keep in mind. You have this thing similar like this, but you need to find out the b. Here is a, here is a. You don't know the b, so you make 8 split into 2 by 4 so that you find your b. Minus 2 times x times 4. So that guy is your b plus 4 squared. Make sense?
Yes.
You might say, hey, I don't have the 4 squared. I know, but that's why you do it, and then you will balance it. Plus 1 is the guy you copy down. This term matching. This is the extra thing. To balance, you will minus 4 times this guy square. Minus 4 times 4 square. And then you need to tell me this correct. Who is this? Who is this? Who is this?
X minus 2 squared.
X minus 4, this is your b.
Oh,
X minus 4 parentheses square, right? And then minus, this is 64 plus 1, negative 63. That's it. Okay?
okay.
So if you didn't get this part correct by yourself, you have a second chance to do here by yourself correct. Any other student want to walk through with me for the completion of the square? Unmute yourself. Next. Ethan. You get this part correct?
Yeah.
Why you didn't send to me?
Oh, let me do it right now.
Okay, then tell me, based on this equation, who is this ellipse center?
And 0. Oh, negative a half. And
Negative half, and then?
Negative 3/2.
Yes. Makes sense?
Yeah.
Foci. If you want to get the foci, you want to first get your a square, b square, right?
Yeah.
Who is a square? Oops. Who is a square?
2 square root 2.
Hold on. A square is 8, okay?
Yeah.
B square is?
4.
So c square is?
4.
4. So c will be?
2.
2. The foci is what? This is in which direction? X or Y?
Horizontal.
Horizontal direction. So the foci is going to, starting from the center, move the left, move to the right by C. Make sense?
Yeah.
So foci is?
2, 0, negative 2,
Oh, wait. This is not 0, 0 anymore.
Oh.
You will start from this. You will start from this, so you will do this guy minus 2, right?
Mm-hmm.
And then you will do this guy plus 2, right?
Yeah.
Does this make sense now?
Mm-hmm.
Let's do this guy. Change this to an improper fraction. How much is this?
Positive 3 over 2.
Okay, this is positive 3 over 2. For this one,
Negative 5 over 2.
thank you. Make sense now?
Yeah.
Now go ahead. Find the A. A is how much?
2 square root 2.
B?
2.
You will start from the center. You will move left by this. You will move to the right by this to get the endpoints of the major axis. Go ahead.
So center negative 1/2 minus 2 square root 2.
Comma.
Negative 3 over 2 minus 2. Oh,
This one, no. This
Yeah.
guy is only center. Go left, go right. Okay?
Yeah.
Go to this one.
Negative 1/2 plus 2 square root 2. Negative 3 over 2.
Okay. Now let's get the endpoints of minor axis.
Negative 1/2 comma negative 3 over 2 plus 2.
Good.
And negative 1/2 comma negative 3 divided by 2 minus 2.
That's it. You can simplify. Okay. Yeah, we will keep going. Eccentricity. Go ahead.
Eccentricity is 2 divided by 2 over, so 1 over square root 2, so 2 square root 2 over 2.
Yes. If you get a eccentricity greater than 1, that's wrong. Eccentricity for ellipse is between 0 and 1. For hyperbola, it's greater than 1. Now let's do here. Lattice rectum. This is the horizontal direction. So you will start from the foci. You will go up and down by how much?
By
B squared over A, right?
Yeah.
B squared over A will be?
4 over 2 square root 2.
Good.
So 2 square root 2 over
2 over square root 2, which is square root 2, right?
Yeah.
So go ahead.
So this is plus negative 5 over 2 comma negative 3 or 2 plus minus.
Yeah, they give us 2 blank, so we can write down this in 2 blank location, right?
Yeah.
And then let's do the second one.
The second one is 3 divided by 2 comma negative 3 divided by 2 plus or minus square root 2.
And then 3 over 2, right? And then negative 3 over 2 minus square root 2, right?
Yeah.
So this figure out this full lattice rectum endpoints. Find out the 2 foci and go up, go down, go up, go down by B squared over A. That's it. Okay, number 3. If you really feel confused or really feel sad because this part make you feel very, very hard, this is quite normal. This is the last sessions in the Algebra 2 semester. It's supposed to be hard. That means you need to study ahead of your school. Next one, go ahead. Do this guy. Completion the square by yourself on number 4. Claire, double check your first step. This 4 move to the other side is negative 4. This is positive 4. Move to the other side is negative 4. Double check your work. Yes, we are doing number 4 right now. Claire, very good. So far, I only see you did correct. Andrea, unmute yourself. Let's do this together. So we first take care of the x, okay? 5x squared plus 10x, correct?
Yes.
And then plus y squared minus 4y plus 4 equals 0. So far, so good?
Yeah.
So you take the 5 out. So this becomes x squared plus 2x, yes?
Yes.
I will put 2 times x times 1, which is 2x. In this way, I quickly figure out my b. b is 1, so 1 squared is 1. So far, so good?
Yes.
I know that this is something I don't have it originally. I will keep it in mind later on. I will balance to the other side. And when you see this, you will feel happy because this is who?
That is 1 times y squared minus
Y minus 2 parentheses square, right?
Yeah.
Y minus 2 parentheses square. Because this guy square is y squared. Minus 2ab minus 2ab. This is minus 4y. Plus b squared, which is 4. Equals, look. Previously, I don't have anything here. Now I add a 5. To balance, I have to put another 5. Yes?
Yes.
So this becomes 5 times who?
X squared.
Plus 1, right?
Yeah.
Plus y minus 2 squared equals to 5. And then you divide it by 5 for everyone. So this becomes x plus 1 squared over 5 over 5 is 1. So you put a 1 here. Yes?
Yeah.
And then, because I noticed that 1 is smaller, so I'm going to shift to the right. I will leave the space for my y squared stuff. So y minus 2 squared over who? Over 5, right?
Yeah.
This plus this equals 1. Make sense now?
Yeah.
Good. Let me see. Claire is the first person get this correct. Vienna is also correct. Haley is also correct. But I want you to shift this guy to the left. In that way, you will not confuse with A and B. And then let's see. Who is the center then, Andrea? Who is the center? You want to make this equal 0? Your x is?
Negative.
You make this equal 0, your y equals? 2. Now let's get the, so can you tell me who is A? A squared is?
A squared
Is 5. So A is the square root of 5, right? B is 1. C squared equals to who?
4.
C squared equals to 4. So C is 2.
2.
So the foci, this is vertical direction, right?
Yeah.
Hey, this is vertical direction. So you will move from the center up and down by C value. Go ahead, tell me your foci.
It's
from this center, you will go above by C, go down by C.
-1 plus and then 2 plus 4.
Next.
And then -1, 0.
0. Endpoint of major axis. You will starting from the center. You will go above by A, go down by A. Go ahead. Major axis endpoint.
It's -1 and 2. Is it
that one? Yeah, you go up by A, go down by A, right?
okay?
Make sense?
Yeah.
Okay. Last one here, minor. If you go left by B, go right by B, go.
It's -1 minus 1, so it's
Negative 2. And then?
It's 0, 2.
Yeah, if you have to go to the restroom, you rush to the restroom. That's it. Okay?
Okay.
All right, go ahead, do by yourself. Lattice rectangle based on the location of your foci. This time, you first calculate the b squared over a. And then you go left by b squared over a, go right by b squared over a. For this, for this. So you will have the 4 points. When you finish, write down, send me a picture for this. Okay? I also rush to the restroom so that I don't take break, so that everybody can ask me questions after 18. Very good, Annie. Ethan, double check your work. B squared over A, recalculate the value. Very good, Vienna. Yeah, Catherine, very good. Claire. Let's go ahead and get the B squared over A. B squared over A equals?
1 over 5.
1 over square root 5.
Square root 5.
Which is square root 5 over 5. Correct?
Yes.
So how do we write down the lattice rectangle endpoints?
You do -1 plus square root of 5 over 5, 4,
Uh-huh.
comma 4.
Yes.
And then -1 minus square root of 5 over 5, comma 4.
Good. The other one.
And then -1 plus square root of 5 over 5, comma 0.
Good.
And then -1 minus square root of 5 over 5, comma 0.
Yes. Eccentricity will be?
How do you get eccentricity?
C over A?
C over A. Let's see.
2
2
over...
square root of 5.
Yes. This is 2 over 5 times square root of 5. Okay? Yeah, when students say, oh, how do you know this is less than 1? Well, square root of 5 is 2.236. So this is less than 1. Okay? Here is a quick summary. When you have a circle, C value is 0. So this is a circle. Eccentricity is 0. For the ellipse, the C is less than A, but C is positive. So the eccentricity between 0 and 1. In the future, when we learned polar system in pre-calc, we will see, oh, for the parabola, the eccentricity is 1. For hyperbola, which we will learn next class, eccentricity is greater than 1. Okay? Next, we will have something different. This question is only showing you they didn't give you an equation. You don't need to complete in a square, but they give you the x-intercepts, y-intercepts. And you notice that these are all symmetric over this center. So immediately, you will be able to draw it. -2, +2, comma 0. 0, comma 3, 0, comma -3. So the y direction, this guy is 3 square. The x direction, this is 2 square. So you have this equation easily. And then for the next one, let me call student. Sudisha, you have the foci and you have the major axis. The definition of the major axis length is 2a. Every student, please pay attention. Major axis length stands for 2a. Thus, if you have the ellipse, the major axis length, this is a, this is a, so total is 2a. So when you see this is 10, you say, okay, your 2a is 10. And then for here, you are supposed to know another parameter. So, Sudisha, this means what? This is your B or your C, or what else? This is your C, right?
Yes.
Foci. You see these two guys is symmetric over 0, 0. So that means it's your center 0, 0. So your C is going to be 3. And your major axis is going to be that length is 10. So A is how much?
5.
5. Can you get B squared? B squared is?
16.
Yes, B squared is A squared minus C squared. Okay, now can we have the equation? Do you think this is a horizontal or this is a vertical? Look.
Horizontal.
Yes, your foci is plus minus on the x-axis. So this is horizontal. Go ahead. What is your equation?
X squared over 25 plus y squared over 16
equals to 1. That makes sense now?
Yes.
Okay. Next one, Vienna. This time you see a new term. And students say, oh, you make my brain so hurt so much today. Learn so many things. Summation of foci radii. This is the beginning. I show you guys the YouTube video. You have the 2 nails. You have the string hold these 2 nails. And then you can draw with a pen. Foci radii means this is your ellipse, 2 centers. Radii means radius. So this is one of the radius. This is the second radius. Sum of foci radii means these 2 guys summation. So as what I already showed everybody, when we derive this formula, these 2 plus together equals to how much, Vienna? This guy plus this guy equals how much when we derive the formula at the beginning of the class?
X minus X.
So this is this.
Oh.
That guy. Yes?
Oh.
This is called sum of foci radii. The 2a has another name. It's called sum of foci radii. Very often, students, when they say the name, if they didn't pay attention clearly, they feel so scared. They don't know how to solve. Simple. This is 2a. Okay? So 2a equals 14. All right? So a is how much?
7.
A is 7. Now look at this. Minor axis. Minor axis means what? Look at this. This is a 4, and then you have a go to the left by 6, go to the right by 6. This is a minor direction. So this ellipse should be vertical or horizontal?
Horizontal.
Wait. Hold on. This is a minor one. Yeah, so that means minor one is horizontal, so major one is vertical.
Yeah.
Makes sense now? Okay. So this first minor endpoint is 4,6. Second minor is for -6. So the center is the midpoint. What's that?
4, 0.
4,0. This that tell you A value or B value? B value, right? B is 6, right? Now you have the center at 4,0. You have your A, you have your B, you have the center. It's vertical. Tell me the equation. Go ahead.
X squared over
Y, yes, y squared over.
Y squared 36.
Over 7 squared, which is 49, right? Plus?
Wait, is it not X squared?
No, it's not X squared. It's the vertical direction. It's a vertical direction. Yes?
Oh, right.
Yeah, it's a vertical direction. Plus? X minus? X minus 4 printed square, right? Over?
36.
Equals?
1.
1. That's it. Make sense? Next. Abby. Let's try this.
So wait, so eccentricity is that
C over A, right?
yeah.
Okay. What does this mean? First, center is?
The center is 0, 0.
Yes. Center at 0, 0. And the major endpoint is going up or going down. So this is a vertical one or horizontal one?
Vertical?
Yes. From 0 to 10, that's whose value?
Wait, from 0 to 10?
Yes, that's who?
A?
A, yes, that's A, right?
Yeah.
0, 0, you go up by 10, go down by 10. This is the two ends points of the major axis. Now you have the A is 10. So your C is?
4.
Okay. And then let's get the B. B squared equals?
Wait, B squared equals C squared, wait, A squared minus C squared.
Yes. Go ahead.
So B squared equals 10 squared minus 4 squared.
How much?
84.
Go ahead, the equation.
Wait, so
Vertical. Y squared over who?
Y squared over 100.
Yes.
Wait.
Yes.
Yeah. Okay.
Plus
X squared over 6. Wait, no, over 16. Wait, over 84.
Yes, that's it. Make sense?
Yeah, kinda.
Okay, because it's the first time after practice, when you do this again, you will feel better. Okay. Number 13. Joanna, look at this. This tells you the C value, right?
Yeah.
Because plus minus means it's symmetric over 0, 0. So your C is?
2 square root 6.
And then this minor axis, that is minor axis. So how much is 8? If you draw the ellipse, that is your major axis, which is 2A. This is your minor axis, which is 2B. Make sense?
Yes.
So
Equals 4.
yes, so B equals to 4. Can you get A, please?
Yeah, so A squared equals to B squared plus C squared. So A squared equals to 16 plus 2 square root 6 squared.
This guy square, it will be 4 by 6, 24, right?
Yes.
Which is 40. Okay?
Yeah.
Now,
Yeah.
Go ahead, get the equation.
Y squared over 16 plus
Y squared over, this is in which direction? In X direction, right?
Yeah, sorry. It's X squared over 16.
X squared over 40.
Oh, sorry, yeah. X squared over
Plus
40 plus Y squared over 16.
Equals to 1. That's it. Okay?
Okay.
Yeah. We still have more questions, but I put my notes in details. So it's already 8:10. If you have to go, you can go. If you have questions, you feel confused, you stay with me. You can ask me for help. Okay, all the question. Go ahead, everybody ask me.
Earlier you mentioned something about like when the value is smaller, you would shift it over. Can you please clarify?
When the value is smaller, you shift it over.
I'm not sure which one it was, but you mentioned it multiple times, but I never fully understood what it meant.
Hold on, do you remember where did I mention that question?
I think it was in the problem you did with me. It was 5x squared plus y squared plus 10x minus 4y squared.
Yes, this one, right?
Yeah.
So I try to completing the square. So here I take out the term belongs to x. So this is a 5x squared plus 10x. And then here y squared minus 4y plus 4. When I want to completing the square, I first take the 5 out. When I take the 5 out, I have x squared plus 2x times 1. It's 2x, but I would like to write down 1 because this clearly tell me who is the b value. So I will plus this 1 square. So far, so good.
Yeah.
And then plus this guy. This guy is y squared minus 2 times y times 2, because 2 times 2 is 4. And then you plus 4 is just happen to be 2 squared. So this one is lucky. You have this term ready already. And then, so for here, previously it's 0, but right now you should plus 5 times 1. Because when this 5 times 1, you have a 5 and 5, which you can cancel them so that this equation is equivalent as the original one.
Yeah.
Does that make sense?
Yes.
For the small shift, I think I'm talking about this. So you have this ellipse, and I already said who is greater, who is major. This 5 means a is square root 5. So this a is greater than the 1. Under the x is 1, under the y is square root 5. So of course, it's going to be vertical direction, right?
Yeah.
And when I want to do the lattice rectangle. Lattice rectangle, if it's a vertical direction ellipse, you want to shift from this focus. This is for parabola, only one point as a focus. That's why you call focus. For here, you have two focus, you call foci. For this vertical direction ellipse, your end point of lattice rectangle, you will go shift to the left, shift to the right, shift to the left, shift to the right by b squared over a. That's what I mean. So you find,
when you're finding the equation, when the value is smaller, is it always b?
right. You make the b as a smaller one. You make the a as the greater one. But next week, when we learn hyperbola, this will not be true for hyperbola. For ellipse, who is greater, who is a? We have to make sure this thing, okay?
Okay, yeah. Thank you.
Just practice, then you will feel better. When school reteach this part, you will feel way more better. Yeah, if it's the first time you see this question, you really feel overwhelmed. But after you practice, you will feel better. Okay?
Thank you.
Yeah, thank you for staying with me. Bye-bye.